Okay, in this video we're going to just really quickly do some review of antiderivatives. Again, this is just a series of different things we're going over to get you ready for the Chapter 4 test. So antiderivatives, remember, just means what function would have given the derivative of x cubed. Well, the function, the first thing we have to do is raise the power. Okay, it had to be an x to the fourth because as we find the derivative we drop a power. Well, then we just divide by the new power. I like to write it as a 1/4 instead of divided by 4. Okay, and just verify, if I was finding the derivative of this, I'd bring the 4 out front. 1/4 multiplied by 4 is 1. I drop the power, and that would bring me to x cubed. And of course, we've got to remember to put a plus c because there could have been a constant that we lost when we found the derivative. Okay. This one, I want to start by just rewriting this as x to the 1/2. Okay, because I think it will be easiest to look at it that way. So as we find the function, we raise the power. So you've got 1/2, add 1, that brings us to 1/2, but I like to write it as 3/2. And then we divide by 3/2. Well, let me just write that. I'm going to write divide by 3/2, but I don't really like to do that. I'd rather have, I don't want a fraction in a fraction. Well, dividing by a fraction is the same as multiplying by the reciprocal. So instead of dividing by 3/2, why don't I multiply by the reciprocal of that, which is 2/3. Of course, the antiderivative of 7 is just 7x, and we put a plus c on the end. Okay. Next, 1 over x. Well, let me put just below that, this is the same as x to the negative first. And I do that because in this case, if you raise the power, you'd get x to the 0 and then divide by the new power. Well, this isn't going to work. This is a red flag. Okay, when raising the power would bring you to x to the 0, that it's got to be some other function. In fact, it is. The antiderivative of 1 over x is the natural log of x. Now you can't just assume every fraction is going to have natural log in it. It's not. This is reserved. Natural log is reserved for when the power, when you raise the power, it would bring you to x to the 0. So for example, if it were 1 over the square root of x, well, that's x to the negative 1/2. You wouldn't need natural log then. This is only for when it's x to the negative first. Okay. Well, the antiderivative of cosine is sine, so this will stay with the subtraction. We won't change signs there. And then we put a plus c. Okay. Now finally, this last one, this is not something that's on a test, but I just thought would be kind of interesting to look at. Let's start with finding f prime, because you see we have the second derivative. So we raise the power, divide by the new power, put a plus c. Well, then when we go to find the second derivative, we raise the power again. Divide by 3 means this becomes 1/6. Antiderivative of a constant is a constant multiplied by x. And then we maybe introduce a new letter as a new constant. So it's kind of a weird looking thing. Oh, and I accidentally put it should be f of x. But it kind of shows how we can keep working back step by step.